Hi everyone, this is Ram from Informatica Global Customer Support Team. In this video, we'll see what is TLS in PowerCenter. This is a part 1 video. So in this video, we'll first understand all the terminologies that is present in the TLS in the PowerCenter, and in the part 2 video, I will go on with the demo. Now, what is the agenda of this video? Now, in this video, we'll learn what is HTTP, HTTPS, SSL, and TLS. So in this, we'll see how SSL and TLS works, what are the encryption methods that are present, what is the history of SSL and TLS, where TLS is being used, why we need to use a TLS, how TLS works, what is a digital certificate, what is a chain of trust, and what are the contents of the certificate. And we also see key store versus trust store, the difference between key store and trust store. So in the next part, I will talk about the demo, how we need to configure HTTPS and the TLS in the node in the PowerCenter. So let's first understand all the terminologies here. Now, explanation. So first, let's start with what is HTTP. So we all know HTTP is a most widely used protocol. So it is a protocol that is used to view web pages. For example, when you type www.google.com in the browser, it will automatically redirect to HTTP, either HTTP or HTTPS. Nowadays, every website is HTTPS. That means security. So it has more security, HTTPS. So that's why most of the websites, when you type amazon.com, it will redirect to either HTTP or HTTPS, HTTP. So that's why it is by default, it is saying the protocol is used is HTTP. Now, what is HTTPS? HTTPS is very simple. When you add S to the HTTP, it is HTTPS. That means S is nothing but a security feature. So how this security is being achieved? So this security is being achieved by using SSL or TLS protocols. So that's why SSL and TLS is a protocol which is being used in the security feature. Now, what is the difference between this HTTP and HTTPS? For example, consider you are about to shop. So you went to shopping.com. For example, amazon.com you went and you have selected all the items and you have added to the cart and you are about to make the payment. Now, for example, Amazon is a HTTP website. For example, Amazon is a HTTP web server. So then when you are about to make a payment, then you need to enter the credit card or debit card information on the passwords. So if it is HTTP, then all the passwords, debit card, credit card information, there might be a chance that is vulnerable to the hacker. But if it is HTTPS, it is not vulnerable, because when it's HTTPS, all the data that is transferred over the public internet is encrypted. So whatever you send, for example, your password is ABCD. When it is going to the public internet, it is being encrypted. So it will be like this 78 hash everything. So there is no chance of hacker being hacked this information. So that's why most of the websites, even nowadays, Google is penalizing all the websites which is not using HTTPS. So HTTPS is very powerful nowadays. And in the PowerCenter, when coming to the PowerCenter, we have HTTPS enable admin console, and we also enable TLS in the node. So these are the two different concepts. Now, when it's coming to the admin console, we'll type HTTPS : / the PowerCenter server machine name and the : port number which you are about to access. So then if it is HTTPS enabled, then it will redirect to HTTPS and will access to the PowerCenter server machine. Now, if it is only HTTP, then we'll use HTTP. But nowadays, most of the customers are enabling HTTPS. So I will talk about that also, how to enable HTTPS in the PowerCenter as well. Now, in the node, we'll enable TLS. I will also talk about that. Now, what are the protocols? SSL and TLS protocols. Now, SSL protocol is nothing but it is used to ensure security on the internet. TLS also same. It is used to ensure security on the internet. It uses public key encryption. So what is the difference between these two? So there is nothing much difference. In the past versions, we call it as SSL, which is secure socket layer. Nowadays, in the recent version, they have changed the name to transport layer security, which is TLS. So that's why it is successor to SSL, and every company is using now. Now, high-level handshake. For example, let's see what is a high-level handshake. Now, when you're about to connect to a website, for example, you are connecting to the admin console URL in the PowerCenter. Now you will open the Chrome and you will type HTTPS : / and your PowerCenter server host name and the : port number. Now what it will do, the browser here, when you're accessing admin console in the PowerCenter, your browser is a client and your server is a PowerCenter server machine. Now what it will do, the browser will say, hey website, identify yourself. Now what it will do, the web server, that means the PowerCenter server, it will send a copy of its SSL or TLS certificate. So in the PowerCenter server, we'll configure this. This I will deal later. So these certificates will be sent to the client, that means to the browser. Now browser will check, and if it says I can trust you, so then it will say, the server will say, okay, let's exchange the encrypted data. Now the data is being transferred. This is a high level. Now let's see what is the TLS encryption methods. Now there are two encryption methods. One is symmetric and asymmetric. Symmetric encryption is nothing but there will be one key, that is public key. So the server will give the public key to the client. For example, consider here is a client, that means in the browser. Okay, now the server is somewhere. Okay, now the server will have the only one key, which is nothing but a public key. So this public key will be given to the client, and the client, it will take the public key and it will encrypt the data and it will transfer the data to the server. And now server will decrypt the data using the same public key, and the data transformation happens. So this is lightweight encryption because there is only one key, which is nothing but a public key, and uses 128 or 256 bits. Now coming to asymmetric encryption, here it will have two keys. One is public key and private key. Now what it will do, the server public keys will always be at the server side. For example, this is a client, consider, and there is a server. Now server has public and private key. Now what server will do, server will send public key to the client. Now client, using that public key, it will encrypt the data and it will transfer the data to the server. Now server, what it will do, instead of using public key as in a symmetric, it will use as a private key and it will decrypt the data. So there is much security because the private key will be with only server. There won't be any sharing of the private key, only public key will be shared. So that's why asymmetric encryption is more powerful, and it uses 1024 or 2048 bits. Okay, now how handshake happens in the PowerCenter. Let's see whether it is an admin, whether you are accessing admin console URL or while you have enabled TLS in the node. When you enable TLS in the node, right, then the communication between the application services and the node will happen. So the node will become a server and the application service like RS will become a client. So RS client will connect to the node. Sometimes when it is communicating between the application service, for example, IS is connecting to the RS, then IS will be the client and RS will be the server. So it happens interchangeably. So the server and client will be on the node. Now, when it is admin console URL, then the client will be always the browser. There is nothing. So that's why the client will be always in the browser and the server is always the PowerCenter server machine. Now, how handshake happens? Let's see. So there is a client. Now what it will do, it will tell hello server. Now the server will say, hi client, here is my public key. That means it will send the public key. Now client encrypts the data using public key. It will encrypt, that is symmetric encryption as I mentioned before, and server uses its own private key and decrypts the data. This is asymmetric encryption. Now the session got established. Okay. Now after you close the Chrome, right, if you open tomorrow again, that same thing will happen. So in the PowerCenter, in the initial handshake, we'll use asymmetric encryption, and in the later on handshakes, we'll use symmetric encryption. Okay, this is a difference we use in the PowerCenter. And what is the history of SSL and TLS? Now let's talk about this high level history. So in the SSL is first published in 1995. Okay, now but it was deprecated in 2011, which is a first one is a security flop, and the second is 1996. It was deprecated in 2015. It is SL 3.0. Next in 1999 TLS 1.0. So they have changed the name to TLS, Transport Layer Security, and in 2006 they have opened TLS 1.1 and 2008 TLS 1.2, and in 2018 we got TLS 1.3. But in our PowerCenter we use only up to TLS 1.2. Now we are, and most of the customers are also asking, they want to enable only TLS 1.2, not TLS 1.0 and 1.1. So for those also we have steps, and TLS 1.3 is not being implemented in PowerCenter. We might expect this in future releases. Now, where we use TLS? Now, you might wonder whether we are using TLS only on the websites. No, it is everywhere. If you see on websites, HTTPS, as I told, HTTPS means which is HTTP plus TLS. Next, email. If you see, everybody is talking about SMTPS, which is nothing but SMTP plus TLS. Now, file transfer protocol. So FTP plus TLS. So nowadays TLS is everywhere. Now, why TLS? Now, what is that? Why we need to use TLS? First thing is authentication. So this is a main important one. The authentication is nothing but verify the identity of the communicating parties. That means whenever a client is communicating with the server, the client need to know, like the client need to understand whether it is connecting to the correct server or not. That means trusted server or not. So that's why authentication is very important. Means we access the authenticated websites, not the fake one. So, and the second thing is confidentiality. That means protecting the exchanging data from unauthorized. No one should access. So that's why in HTTPS, no one can't access, because data is being transferred in the encrypted form. It won't go in the plain text. Next, integrity. Integrity means there should not be any change in the transmission of data. If you are passing ABCD, then server should receive ABCD. It should not receive EFGH. So that is integrity. Now, how complete handshake? Now, in the previous, we have seen the high level handshake. Now we'll see complete handshake in PowerCenter. So what happens is, when you access any admin console URL, the client is browser, as I said, and the server is PowerCenter server machine. That is first thing. And when you are enabling TLS in the node, then the server is node and the client might be RS, or else sometimes the server might be RS and the client might be IS. So anything, it uses the same handshake. So if you see here, first it is client hello, first step in handshake process. Now, whatever the information it is getting, it is going version, client random, session identifier, cipher suit, compression method. So if you see, this is the one, step one. Now, the second one, server will also tell hello, as I said in the previously. So now the server, if you see, it will transfer certificate. So what is certificate? I will tell you. So it will transfer the certificate to the, as I said, certificate means, as I said previously, it is public key. Public key, it will transfer to the client. Now client responds to server. Now when it is verified, so okay, the client is trusted, so then it will exchange, client key exchange, change cipher specification, and finished. Encrypted handshake is finished here. Okay, now server responds to client. Now the server will respond like session ticket. It will send a session ticket. So if the client has session ticket, then the next handshakes, it will use only symmetric cryptography. It won't no need to use all the handshake again. So that's why session ticket is very important. For example, the session ticket might leave for 20 minutes or 30 minutes, like that. Next, change cipher specification and the finished. If you see here, change cipher specification. So what is the version that is being used? TLS 1.0 is used. And handshake protocols, if you see, TLS 1.0 and the length is 48. Okay, now after client and server are agreed, then application data flow, so then the actual data flow starts. See, if you see, application data protocol, HTTP over TLS. Now I have a doubt. I got a doubt. What is the doubt is, I have a client, okay, and a server. Now, as I said, server sends its public key to the client, as I said. So then client will encrypt the data using the public key, and it will send to the server, and server will decrypt the data using its own private key, which is asymmetric and which is fine, which happens in the PowerCenter. Now the doubt I got is, whenever it is server is sending a public key, so it is sending public key over a public internet. Not only I will present in the public internet, there might be hacker present in the public internet. Now consider, hacker changed the public key and send his own public key to the client. Then client thought that it is server's public key and encrypted the message, and then hacker can easily decrypt the message. So there might be a chance that it might occur. Then whenever the server sends, the hacker might change and he will send to the client, and the client thinks that, okay, I got public key from the server, then it will encrypt and it will send, and hacker will decrypt the message. Then there is no chance, then there is no authentication. That means there is no confidentiality here. So how we need to overcome this one? So we can overcome this one by using certificate. So if you see, certificate plus public key will be sent to the client. As I told previously, only public key will be sent to the client. But here, because if you send only public key, because public key is just a number, there might be a chance that, as I told previously, there might be a chance that hacker might change the public key and he will send his public key. So that's why with this public key, we need to put some identity. That identity is nothing but a certificate. So along with the public key, we need to send the certificate. So now whenever in the PowerCenter or anywhere, we'll put the public key directly in the certificate and we'll send the certificate. So that means whenever we talk about certificate, that means certificate contains public key, as well as it contains some other information like the email, what is the distinguished name of the server and everything. Now this will be sent to the client. Now there are two types of certificate. One is self-signed certificate, one is CS signed certificate. Okay. Now consider when you are sending public key, there might be a chance of hacker might hack. That's what I said. But consider certificate is also like a passport. Certificate is like a passport here. Okay, consider now. But what if hacker makes passport under server's name and with the server's public key? So what if a hacker makes passport you under the server's name with the server public key and send to the client? Then client also thinks that it got from the server machine, right? So there that can also happen. So that's why in order to not avoid this one, we have a certification authority, which is like we have a passport authority where they will verify our identity and they will give the passport. In the same way, we have a certification authority where they will verify our certificate and they will issue a CS signed certificate. So that's why instead of self-signed certificate, CS signed certificate is more powerful. Now, how certificate signing happens? Now let's see. Server has a public key comma private key. So private key, as I said, it will have two, which is asymmetric encryption. Now what it will do, server creates a CSR. CSR is nothing but certificate signing request. Okay, CSR contains public key plus name, domain, organization name, email, everything. Now signs the CSR with his private key. So server will sign the CSR with his own private key only and send to the CA, which is nothing but a certification authority, which is a passport authority. Now passport authority, what it will do, certification authority, it will verify the certificate and signature, and CA will sign the certificate with their own private key. CA will have their own private key and it will send to the server. Now, whenever server gets, for example, consider here is a client and here is a server. Server has given CSR to the CA and CA has given back to the certificate to the server. Now, whenever server receives a certificate, then whenever the communication is happening, first server will send this certificate, CA signed certificate, to the client. Okay, now client, what it will do, it will verify. So for example, if you consider in the PowerCenter, when you access admin console browser has trust store certificates. So whenever the CA certificate is present in the browser trust store, that means whatever the CA which is getting, if it is present in the browser trust store, that means then the browser will identify as a trusted one and it will communicate with the server. That's what it happens. So server will send the certificate and client will verify this certificate with this public key of the CA. Now hacker cannot replace because he doesn't have CA's private key to make fake certificate. Okay, so that's why there is no chance of hacker involved when you use a CA signed certificate. Now, what is a chain of trust? Why we need to use a chain of trust? For example, consider the CA in the worst scenario, the CA which you got is a fake one. Fake CA you got, and you have taken that fake CA certificate and you have given to the client. Okay, now meanwhile the CA has given his private key to the hacker, consider in the worst scenario. Now then hacker will also have this have the CA's private key and he will sign his own certificate and he will send to the client and he will able to decrypt the data from the client. So this might also happen. So that's why we'll follow the chain of trust. Chain of trust is nothing but instead of following only one authority, we'll have 2 or 3 authorities. So if you see self-sign, so root certificate, this is the bigger one, bigger CA to sign their own certificate and also sign support units. Now this root certificate, what it will do, it will sign intermediate certificate authority as well. Now this intermediate certificate authority will sign any certificate. Okay, now whenever you contact this root certificate, right, this root CA, then they will give root certificate, intermediate certificate, and the server certificate, everything. So these certificates, if you install on the PowerCenter server machine, you need to install, and then if you make a communication, then it will be very secure. Now OS and browser stores a list of certificates of trusted root CS. As I told, whenever you access admin console, then client will be a browser. So browser will have a trusted root certificates, CS will have. So that's why if you see when you enable HTTPS in the PowerCenter, you won't create trust store certificate, you will create only key store. I will talk about later this one. Okay, now what are the contents that is present in the certificate? Now what's in a certificate? So the certificate digital certificate contains at least the following information. Now the owner's public key it will contain, the owner's distinguished name it will contain, the distinguished name of the CA, next the date, the validity, and the expiry date, what is the version number, and everything it will contain. The serial number, this is a unique identifier assigned by the CA. Okay, these are the contents in a certificate. Now let's talk about the key store versus trust store. Now what is a key store? Now as I mentioned, in the PowerCenter we'll have two. One is enabling HTTPS, and the second one is in the node as a TLS. Now when you enable HTTPS, you won't need to create trust store, because as I said, client is a browser when you access the admin console. So client by default, it will contain all the trusted trust stores. So there is no need to configure trust store. You need to forget about trust store. So when you enable HTTPS, you need to create only the key store. In the next video, I will tell you how to create a key store and all. So what contains the key store? In the key store, we'll have the private key certificate. So as I said, the server private key will be there in the key store, and as well as the public key, it also contains the public key. Okay, now this private key and public key, now this public key will be sent to the client, and the client will receive this information and encrypt, and it will send to the server, and server will decrypt. This is a use of key store. Trust store, so in the trust stores, you should not keep any private key. You need to keep only the public key. So trust store will come into the picture when we enable the second one, which is node TLS. So then we'll use the trust store, which is nothing but a public key certificate we'll use. It is used majorly on the clients. On the client side, as I said, browser will have the default trusted CA certificate, so there no need to configure on the browser machine again. Now the example is must not contain the private key of the server, and the example is CA certificates. Okay, now let me quickly show you one thing here. Now I have logged into my server machine. Now let's see, as I mentioned, in the PowerCenter, we'll enable HTTPS to the admin console URL, and at the node level, we'll enable TLS. Now let's see how the key store files it will contain. Now, as I mentioned, you just remember for the HTTPS, you need to configure only the key store file. You don't need to bother about the trust store file, because the trust store, the client is a browser every time when you access admin console URL. So browser will contain the default trust store in its Chrome browser. So in every browser, so you don't need to bother. Now let's go into the node meta.xml file, and let's see what is the key store file we have given. So if you see the key store file, here it is info home. This is info home and tomcat conf. In this we have tomcat.keystore. So as I mentioned, key store, that is nothing but a Java key store. Key store means Java process. Our admin console process is a Java process. So that's why it is a keystore. We can give .jks also, or you can give .keystore. Both can be fine. Now you can give not only Tomcat, you can give any name. You can give RAM as well. Any name you can give. Okay. Now let me go into that location. cd tomcat cd conf. Now if you see tomcat.keystore file. Now let's see the contents. Let's first see the basic contents, what it contains. So if you see, okay, so yeah. So key store file does not exist. Okay, wait, I have given hyphen here. Remove the hyphen. Now it is asking for the enter key store password. So why there is a password for the key store? As I mentioned in the PPT, the key store file, what is the difference between key store and trust store? Key store contains the private key. So if it is a private one, no one should see it. So that's why we have a password here, key store password. So you need to enter your key store password here. So I'm entering my password. After entering, you can see the content. See, the owner is this one and issuer. This is a self-signed certificate. Okay. So we have generated our own certificate and we are using this certificate to the HTTPS. That is self-signed certificate. Okay. Now we have created a key store file and we have enabled HTTPS on the admin console URL. Now after opening, if you see, it will see the not secure message. So why we are seeing not secure message? Because ours is a self-signed certificate. Okay, so that's why the certificate, which is whenever you click this one, right? Whenever you click this one, Okay, so whenever you click this one, then the request will go to the server machine, PowerCenter server. Thus, PowerCenter server will send the certificate to the browser. Now, whenever the self-signed certificate it is sending, the browser is unable to trust, because the browser will not trust when you use a self-signed certificate. But if you import that self-signed certificate into the browser trust store, then we can remove that not secure message. That also I will deal in the next video. This is only to give you overview. Okay, so you can see the redirection is HTTPS. That means we have successfully enabled this HTTPS. Now, when you enable HTTPS using the CA signed certificate, as I mentioned in the PPT, you have to generate a CSR and you have to give to the CA. Then you will get a certificate. Using the certificate, if you enable, you won't see this not secure message. Okay. Now let's see the node level TLS. So when you enable node level TLS, how to enable, I will tell you in the next video. But when you enable the node level TLS, by default, if you see, this is my info home, and in the services shared security folder, it will contain the key store and the trust store files. So as I mentioned, on the node level, there should be key store and trust store as well, because here sometimes then you might get a doubt, because as I mentioned, trust store should be on the client machine only, but I'm keeping info underscore trust store in the server machine as well, because whenever sometimes our node will be a server and client will be the RS, and sometimes our RS will be the server and IS will be the client. That means the services which is present in the node only, sometimes it is acting as a client and sometimes it is a server. So that's why we need to keep the trust store on the server machine only. Okay, so that's why I'm keeping, instead of with the key store as well, I'm keeping info underscore trust store dot JKS. So this JKS, as I mentioned, JKS means Java key store. It can be dot key store also. I have given as dot JKS dot JKS. Okay, now you might ask, what is the .pem? .pem, these files will be used by CPP process. CPP means if you see, node is a Java process, admin console is a Java process, but .pem, RS and IS is a CPP process. So that process will be those process will use these files. So these are the 4 files. These are default on every PowerCenter machine. It will present in the security folder. Okay, so when you enable TLS using update get one -TLS true, so the TLS it will use all these certificates. These are the default one. Now, if you want a CA sign certificates for this, then what you need to do? You need to first generate a key store, and you need to give a CSR to the CA, and you need to get the certificates, and you need to import into the this info underscore key store dot JKS, and into the info underscore trust store, you need to keep only the public key. Here it will key store, it will contain public key plus private key. So then the secure the communication within the node will be more secure if it is CA. Now, how to enable CA? How to enable TLS using self-sign and CA sign, I will talk about later. Using how to enable HTTPS using self-sign and CA sign, I will talk about in the next video. Now, there will be one other certificate, which is nothing but, if you go into CED, for example, CED server bin. Okay, now let me put CA bundle. So if you see, CA bundle.crt file is also there. Now you might get confused. What is this CRT file? I talked about tomcat.keystore, which is HTTPS. This 4 is for node. What is this? So when you use a HTTP transformation or web service consumer transformation, anything, you will configure one URL, right? Endpoint URL. Now, if that endpoint URL, if this want to trust, the PowerCenter want to trust and connect to the endpoint URL, whatever the certificates that is being used by the endpoint URL, that should be kept in the CA bundle.crt. You need to import into the CA bundle.crt file. Okay, these are the certificates in the PowerCenter server. Now, in this video, we have seen all the basic information about what is a TLS in the PowerCenter, what is HTTPS, and TLS at the node level. Everything we have seen. In the next video, I will talk about the demo, how to enable HTTPS using self-signed and CSIN, how to enable at the node level TLS using self-signed and CSIN. For your references, you can see search.informatica.com, and you can also see our info support channel. If you loved this video, you can give our feedback at supportvideos@informatica.com. Thank you for watching this video.